G'day, I'm Jeff Cumming, and with my co-author Bob Cullen-Jagaman, I'm delighted to welcome you to the new Statistics and Open Science. These are exciting times to be starting off in statistics and research because some important things are changing and they're new for many researchers as well as for students. The good news is that in our experience, these new ways are easier to learn and understand. I should mention that these videos don't cover the full contents of the book, but hit some highlights, and from chapter 3 on, they mainly illustrate how to use Esky, the software that comes with the book, to explore concepts and make things clear. You can certainly use the book without using Esky, but our students tell us that it really helps. Enjoy. In research, perhaps the commonest thing for researchers to do is to seek answers to questions like how much, how effective, to what extent. These are all questions asking for some measure or amount in the answer. And in our example, the question is, what's the support? How great is the support for Proposition A among likely voters? And the answer that our poll gives us is, well, 53% is our best estimate, and there's a margin of error, an indication of the amount of uncertainty of 2% either way. I love drawing pictures, and here's a picture of that result. 53% we call our point estimate, and this interval running from 51 to 55, that's a margin of error above and a margin of error below. This interval is our interval estimate of the support for this proposition in the whole population of all likely voters. I can draw this line on our interval estimate here, and that gives us an indication of the plausibility or relative likelihood that the true value is at these particular points in this interval. So round about the centre, as we'd expect, around about 53, is our best bet for where the true value in the population lies. Up here around 54 to 55, or down here, relatively less plausible values, but notice that even just beyond this interval estimate, there's still a little bit of plausibility, a little bit of possibility. And in fact, this interval we call the 95% confidence interval because calculated from our data, we can be 95% confident that the true value lies in this interval. There's still a little bit of possibility that it's just outside either way. This is a little microcosm of research, and here's what we did. We asked a question about the population, all likely voters, but we can't ask all of them. We have to use a sample, and based on the sample, we calculate our estimates. So it's obviously critical that the sample is representative of the population, that it's not biased in any way. And if we do get a good unbiased representative sample, then it's reasonable to use the results from the sample as estimates of support in the population. That's called statistical inference. We're inferring from a sample to the population, and that's the basis of lots and lots of science. The estimates, typically a point estimate, such as our 53%, and an interval estimate, which we write in square brackets like this, or 53 plus or minus 2%, the margin of error. So we're inferring from a sample, perhaps those 20 people, and we're drawing a conclusion about all of humanity, the whole world, about the particular question we're asking. That's the wonder of statistical inference. Now here's a question. Suppose you did another poll exactly the same but with a new sample. What result would you expect? Maybe you can pause and think about that for a moment. Another question. Margin of error, 2%. Suppose we did the study again but with a larger sample. would you expect the same margin of error, or larger or smaller, and why? So again, pause and think about that. Nothing better than doing a bit of thinking to help understanding and enjoyment when considering these sorts of things. So going back to my first question about intuition, another poll, exactly the same but a new sample, we would expect, as you probably figured out, a result somewhat similar to the same, but probably not exactly identical. Most likely would be round about 53. Quite likely will be within this interval, but actually it's not totally guaranteed it would be. So we can think of this confidence interval, this interval estimate, as telling us about what's likely to happen if we repeated the experiment. Now, what about the margin of error? If we had a larger sample, we would hope it would be closer to the whole population, and so that our estimate would be a better estimate, so that our margin of error would actually be smaller. If we go to the trouble of taking a bigger sample, we hope we get a better estimate, meaning a smaller margin of error. A smaller sample at the expense of a larger margin of error, and that's how it usually works. So here's the research process has 6 steps. First, we ask a question. We design a study to answer that question. We carry out the study, collect the data, and then we apply statistical analysis and draw a picture. For example, our figures there with the 95% confidence interval. And a lot of this book will be discussing how we do that in various different situations, but always within this general research as a series of steps. Then, of course, we have to draw conclusions about what the point and interval estimates are telling us and interpret the results and give a critical discussion of the whole thing. How we set it up, how we chose our sample, did it work as we expected, what we make of the results. And we'll discuss quite often this critical evaluation of what we do. It's vital that you build your confidence to make your own judgments about what's reasonable, what's plausible, what conclusions are justified. And then we think about the next study, because this is a whole research process: question, answers, reflection, next study, moving on, building on the past one. And this is estimation, our general approach to research. And so, in summary, this is what science does. It asks and answers research questions, putting these questions in the form, how much or to what extent? That might seem obvious, but compare it with asking, is there an effect, or I wonder whether. I wonder whether eating a healthy breakfast would improve my mood. Well, for sure, eating a healthy breakfast will make some difference and might be trivial. What I'm really interested in knowing is estimating to what extent eating a healthy breakfast will improve my mood. Will it be trivially different? Will it be usefully improved? So I want an estimate of how much. And of course, an indication through the margin of error of how good that estimate is. If you ask, I wonder whether, you're using dichotomous thinking. Dichotomous, the Greek, cutting in two. That's thinking of the world as black or white. Either it has an effect or it doesn't. But fortunately, the world is not black and white. It's a wonderful kaleidoscope of colours. And so it's much more informative, much better practice to ask always, to what extent, how much? I wonder to what extent my mood will improve if I eat a healthy breakfast. And that's estimation. So our general approach is to go from research questions by climbing up these confidence intervals to seek estimates as answers.